Sir Isaac Newton's life is a gripping tale of triumph over adversity, a solitary genius whose relentless curiosity reshaped our understanding of the universe. Born fatherless and abandoned by his mother at age 3, he grew up isolated, wrestling with inner turmoil that fueled his fierce determination. Picture a young Newton, alone in a rural English village during the Great Plague, gazing at a falling apple and unlocking the secrets of gravity, a moment that would change the world forever. His story isn't just one of cold equations. It's a deeply human journey of obsession, rivalry, and resilience, as he battled personal demons and fierce opponents to forge a legacy that still lights the path of science today. Want to explore the heart of his struggles or the spark of his discoveries? Early life and education, birth and childhood. Isaac Newton was born on January 4, 1643, December 25, 1642, Old Style in Woolsthorpe, Lincolnshire, England. His father, also named Isaac, died 3 months before his birth, and his mother, Hannah Iskof, remarried when Newton was 3, leaving him in the care of his grandmother. This early separation reportedly contributed to his introspective and solitary nature. Education. Newton attended the King's School in Grantham, where he showed academic promise. At 18, he enrolled at Trinity College, Cambridge, in 1661, initially as a work-study student. There, he was exposed to the works of Aristotle, Descartes, and other thinkers. But his fascination with mathematics and natural philosophy grew through self-study of works by Kepler, Galileo, and Robert Boyle. Formative years. By 1664, Newton began developing his own ideas in mathematics and physics. His studies were interrupted in 1665 to 1666, when Cambridge closed due to the Great Plague, leading him to return to Woolsthorpe. This period, known as his Annus Mirabilis Year of Wonders, saw the genesis of his groundbreaking work in calculus, optics, and gravity. Major scientific contributions. Newton's work laid the foundation for classical mechanics, optics, and mathematics. His key achievements include 1. Laws of motion and universal gravitation. Philosophiae Naturalis Principia Mathematica, 1687. Newton's magnum opus, commonly called Principia, is one of the most influential scientific works ever published. It outlined Newton's 3 laws of motion. First law, inertia. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. Second law, F equals ma. The force acting on an object is equal to its mass times its acceleration. Third law, action-reaction. For every action, there is an equal and opposite reaction. Universal gravitation. Newton formulated the law of universal gravitation, stating that every mass attracts every other mass with a force proportional to the product of their masses, and inversely proportional to the square of the distance between them. This explained both terrestrial and celestial motion, unifying phenomena like falling apples and planetary orbits. The Principia provided a mathematical framework for understanding the universe, enabling predictions of planetary motion and tides. It established Newton as a towering figure in physics experiments with light. In the 1660s, Newton conducted pioneering experiments with prisms, demonstrating that white light is composed of a spectrum of colors. He showed that colors are intrinsic properties of light, refuting earlier theories that light was modified by the medium, reflecting telescope, in 1668. Newton invented the first functional reflecting telescope, using a curved mirror to avoid chromatic aberration, color distortion in refracting telescopes. His design, known as the Newtonian telescope, remains in use today, 1704. Newton's second major work detailed his optical experiments and theories. Unlike the Principia, written in Latin, Optics was published in English, making it more accessible. It also introduced his particle corpuscular theory of light, which competed with Christian Huygens' wave theory. Calculus, mathematical innovations. Newton, alongside Gottfried Wilhelm Leibniz, independently developed the foundations of calculus. Newton called his method fluxions, focusing on rates of change, derivatives, and accumulation integrals. His work on infinite series, differential equations, and the binomial theorem was groundbreaking. However, a bitter dispute with Leibniz over priority lasted decades, dividing the scientific community. Newton's mathematical tools were critical, To his physics, enabling precise calculations of planetary orbits and gravitational forces, mathematics, Newton contributed to algebra, geometry, and numerical methods. His work De Analysis, 1669, and Method of Fluxions, 1671, published posthumously advanced mathematical analysis, mechanics, and astronomy. He refined Kepler's laws of planetary motion and provided mathematical proofs for elliptical orbits, alchemy, and chemistry. Newton pursued alchemy extensively, seeking to understand the nature of matter. While less successful, his experiments influenced early chemistry. Theology and biblical studies. Newton wrote extensively on theology, including interpretations of biblical prophecies, though these works were less impactful than his scientific contributions. Career and public life. Academic career. Newton returned to Cambridge in 1667, becoming a Fellow of Trinity College, and in 1669, the Lucasian Professor of Mathematics at age 26. He held this position until 1696. Royal Society, elected a Fellow in 1672. Newton engaged with the scientific community, though he was often embroiled in disputes, notably with Robert Hooke over optics and gravitation. Warden and Master of the Royal Mint. In 1696, Newton moved to London to serve as Warden of the Royal Mint, later becoming Master in 1699. He oversaw coinage reform, combated counterfeiting, and stabilized England's currency. During the transition to the gold standard, President of the Royal Society from 1703 until his death. Newton served as President, shaping the institution's direction and promoting scientific inquiry. Knighthood. In 1705, Queen Anne knighted him, recognizing his contributions to science and public service, personal life, and character. Personality. Newton was complex, brilliant, but often solitary, secretive, and prone to disputes. His rivalry with Hooke and Leibniz revealed a combative side, and he was known for intense focus and occasional irritability. Religious beliefs. A devout but unorthodox Christian. Newton rejected the doctrine of the Trinity and privately held Arian views. He wrote extensively on theology but avoided public controversy on the subject. Health. In later years, Newton suffered periods of mental strain, including a breakdown in 1693. Possibly due to overwork or mercury poisoning from alchemical experiments, he remained active into his 80s, though his health declined in later years. Death and legacy. Death. Newton died on March 31, 1727, March 20, 1726, Old Style, in London. He was buried with honors in Westminster Abbey. Scientific impact. Newton's laws of motion and gravitation dominated physics until Einstein's theory of relativity in the 20th century. His work underpinned the scientific revolution and Enlightenment, influencing fields from astronomy to engineering. Cultural legacy. Newton became a symbol of scientific genius. His ideas inspired generations of scientists, and his image appears in literature, art, and popular culture. For example, the apocryphal story of the apple falling on his head. Controversies. Newton's disputes with contemporaries and his secretive nature sparked debate, but his contributions overshadowed personal conflicts. Modern scholarship recognizes both his genius and human flaws.